In April 2025, the hashtag #FundKaveri started trending across social media. It is incredibly rare for everyday citizens to lobby for something as highly classified and deeply technical as a military aerospace propulsion system. The Kaveri is an indigenous turbojet project. Building a functioning jet engine from scratch requires mastering thousands of moving parts that operate in environments hotter than molten lava. That level of engineering is widely considered the ultimate apex of global military power. This animated Matedistranitstra highly exclusive club of nations that currently possess the capability to build a fighter jet engine from scratch. You can see it is limited to the US, Russia, France, and the UK. India is visibly excluded. Mastering this singular technology is the final, most difficult barrier standing between India and complete aerospace sovereignty. Take a look at the Tejas light combat aircraft. For decades, it has been positioned as the pride of India's indigenous defense manufacturing sector. Curious, but there is a hidden vulnerability. To actually fly, the Tejas is entirely dependent on imported American General Electric F404 engines. That creates an extreme strategic risk. If global supply chains collapse, or if geopolitical tensions result in sudden export sanctions, India's frontline fighter fleet could be paralyzed on the tarmac. Without an indigenous engine, a nation's air defense remains entirely at the mercy of foreign policy shifts. That realization forces us to look back at an initiative launched in 1986. In the late 1980s, the Defense Research and Development Organization was given a bold mandate: build the GTX-35VS Kaveri engine and end the country's reliance on foreign equipment manufacturers forever. The project generated massive early momentum. By 1995, engineers successfully fired the cabine core module, the high-pressure heart of the engine. By 1998, they had rolled out full engine prototypes for ground testing. This rapid progress created a national sense of imminent victory. But those initial laboratory victories masked a brutal reality. Scaling prototype technology into combat-ready, airworthy hardware is an entirely different discipline. This chart compares thrust outputs. The Kaveri engine peaks at 75 kilonewtons, falling far below the 90 kilonewton threshold required to push the Tejas. The problem compounds as the chart shifts to weight. The heavy engine completely destroyed the thrust-to-weight ratio needed for agility. The primary physical bottleneck was metallurgy. Lacking advanced single-crystal material technology, the engine's high-pressure turbines literally tore themselves apart under extreme thermal stress. Overcoming these engineering barriers required advanced testing infrastructure and material science that India simply did not possess at the time. You also have to consider the math. The Kaveri operated on a meager budget of $239 million. By comparison, the US and China spend billions of dollars to develop similar jet propulsion systems. Then came the 1998 international sanctions, triggered by India's nuclear tests. These restrictions completely cut off the Kaveri program from vital foreign components and assistance. Underfunded and isolated, the project stalled. Ultimately, in 2008, the government officially de-linked Kaveri engine from the Tejas fighter program. Losing the Tejas contract branded the Kaveri a public failure, and many assumed India's dream of aerospace independence had quietly died. But DRDO engineers didn't scrap the engine. They adapted it. They stripped away the heavy afterburner, creating a lighter, highly efficient variant known as the Kaveri Dry Engine, or KDE. That KDE variant is nearing official certification following high-altitude trials in Russia. It is slated to power the Ghatak, India's stealth unmanned combat aerial vehicle. The core technology also generated a massive secondary spin-off, successfully evolving into a 12-megawatt marine gas turbine designed to power Indian naval vessels. Taking a stalled laboratory concept and pushing it into functional military drones and marine platforms is a massive, unacknowledged victory for Indian engineering. The #FundKaveri engine movement emerged as specific technical milestones reached the public. Citizens watched as the Kaveri Dry Engine cleared high-altitude trials in Russia and crossed a 100-hour testing milestone, direct evidence that the core technology was finally airworthy. This viral campaign creates a direct line between the laboratory and the taxpayer. By demanding transparency, citizens are forcing defense spending to move from closed-door bureaucracy to a matter of national accountability. The ultimate objective of this digital pressure is the next evolution, Kaveri 2.0. This advanced iteration is designed to provide the 110 kilonewtons of thrust required for India's future fifth-generation stealth fighters. Achieving strategic sovereignty depends on a combination of engineering and political endurance. Titanium and thermodynamics build the engine, but only sustained funding and public resolve can ensure it finally takes flight.